Well, tonight we have something a little different for you that Ken Bertin engineered. He will not be the only speaker. He's going to be joined in some order by Bob Bertin, Chuck DeZella, Angelo Di Donato. Where are you, Angelo?
Right here.
Diana Hall, and Joe Tocco.
And Jeff.
And Jeff McLeod. How come I didn't get him on the list?
Because I added him last couple of days.
Okay.
Last night.
Yeah.
So this is going to be a roundup of the biggest astronomy news stories last year. And each presenter will give you, what, a couple of stories or so?
A couple of stories, basically, or some of the stories will be a little bit longer, a little bit shorter. So.
Okay. All right. So, you know, I'm not going to do intros for all of the speakers. Ken has been the president of this club. He does, as you know, the In the News things each year. He was awarded the John Searles Award and a lifetime membership in this club in recent years. So let's get going.
Okay. Simply, as Dale said, this is going to take about 5 minutes a report. These are the key reports that we were able to do. You saw within the news tonight, it took me about 15 minutes to do 26 reports. So this is very easy to fit into the area. Each individual has selected some that they like. We all voted on them, kind of, and we have the best stories near the end of the story, and each of them have much of the highlights. And I'll be sitting over there and just running the slide situation, and they will be giving it to you. And this is a very, very able group, and we should have a great time with this. So here we go. And let's start it with
Okay.
In the News. Oops, wait a minute. Did I do something wrong? Okay. Here we go.
Okay.
Just first of our speakers will be Angelo Di Donato. He is a past, he was the outreach chairman. And he's going to do it on NASA warp drives. Go
So I'm
ahead.
going to start with this. Let's go ahead and flip over. Go ahead, continue. NASA is working on a warp drive. So I thought rather, you know, just to briefly, what is a warp drive? What do you got to do to get it? That type of thing. So go ahead, Ken. So basically, a warp drive, as its name implies, is a propulsion system based on the ability to warp or deform the fabric of space. Okay, and in doing that, there's been quite a bit of research done. They can actually achieve, if it was possible, you could actually achieve speeds of multiple times the speed of light without violating the special theory of relativity. There's a couple of properties that it depends upon. First of all, microlensing is evidence that space-time can be warped. We know that. Okay, we can see that in the warping of the microlensing of objects in space as the light travels around a massive object. Another aspect of space that allows a warp drive to be possible, if we can build it, is this period of time right after the Big Bang. What happened is, as we now pretty sure, there was a period of inflation where space-time expanded at many times the speed of light. And so these are properties of space that we can utilize to give us a warp drive. So go ahead, Kevin. There was a guy, Miguel Alcubierre, from the University of Mexico, studied the wave equations of special relativity, and in doing so, he discovered a loophole that he thought to himself, he's a big Star Trek fan, he thought to himself, boy, is it really possible that we could do this? So he determined that it is possible, first of all, with the geometry of a donut and with the proper field. He determined that we could develop a warp bubble around the spacecraft. And if you oscillate this bubble, you can actually get the fabric of space or space-time behind the craft to expand. In front of the craft, it contracts. And the end result is that this thing could move forward at quite a velocity of very fast. So about the, speed of light or even beyond the speed of light. So basically, what this thing is doing, it's riding a wave, similar to a surfer on the beach riding a wave in the water. Instead of going through the water, you ride over the water and you're able to travel faster. The same kind of concept applies here for space. So the only thing is, nobody knows what this exotic material is, that they're trying to develop that. But theoretically, if this can be achieved, you can get the warp drive that they're talking about. So go ahead, tell us one more. So a guy named Harold White from NASA caught on to this idea and and wanted to do a proof of experiment to see if this thing would really work, if it's possible to actually warp space and get a result that says, yes, we did it. So what he did was, he took an interferometer, something similar to Michelson-Morley interferometer, if you're familiar with that. Powerful laser, a beam splitter. Half of the light went this way and back through this ring of a very powerful electromagnetic field. The other half of the beam splitter came this way. And what they're trying to do is to see if there's a phase difference as these beams meet up. If this guy here, if this beam, if the wavelength was longer than the other one, then that's an indication that of this achieving a warp condition where one beam is traveling faster than the other one. So the results are inconclusive right now. What they've done was there's a lot of inputs that they have to try to get rid of to see if this thing is repeatable. And so what they've done was they've taken this setup, go ahead, Ken, and they've put it inside a chamber that they isolated for noise and vibration and temperature and all that. What they're doing right now is they're experimenting. No, they're trying this experiment over and over again to see if they can get some repeatable results. So far, it's somewhat inconclusive. This is the process. This is the process that NASA follows. Initially, you want to do something, but you have no idea how to do it. Yeah, after that, you get to a point where you're starting to understand. You're starting to understand the physics behind it. Again, no idea how to do it. So right now, they're right at that point there where they think they have an idea of how to go about doing it. They're getting some positive results, not repeatable, so they can't make a positive statement. But they're making progress. There's a lot of there's a lot of support in the scientific community about this possibility. Next.
That's it.
Oh, is that it? Oh, okay. So we'll see. We'll see what
they're thinking of this at all is pretty cool.
Yeah. Theoretically, if they can, if you can achieve this negative energy, which is energy from space, by warping the fabric of space, you can actually achieve this.
Okay, now one way to consider the testing for the phase differences is consider a spinning mass. A heavy spinning mass, and you have two very sensitive wave interferometers interacting with themselves in a straight, carefully aligned course. Now, if you want to measure for any interference from any inertial disturbances, you can wave a mass, a significant fraction that can be measured relative to it to find out if there's any mass displacement.
Just by virtue of the spin?
Yeah. One way to deal with that is a series of a couple of different ways I come up with, such as
I'd like you to do this and continue, but we really don't have the time to do it. We really are out of time on that.
The result is very sensitive.
If we have time at the end, we can
Okay.
we can definitely do that. Our next speaker is Bob Tremley, and he is going to give you news on the International Space Station and also astronaut news. Did I do it from here? Yeah. Oh, back here.
There we go. We're good to go.
Okay, last August 19th, Russian scientists conducting experiments on the outside surface of the International Space Station made a puzzling discovery. Samples from illuminators and the surface of the space station were found to have traces of sea plankton and other microorganisms, but scientists were baffled how they got there. Results of the experiments are absolutely unique. Chief of the Russian IIS orbital mission, Vladimir, oh heavens, Soliev, told the ITAR task, "We have found traces of sea plankton and microscopic particles on the illuminator surface, and this should be studied further. Study shows that sea plankton and organisms can live in space despite the lack of oxygen, zero gravity, extreme temperatures, and cosmic radiation, and they prove these organisms can develop. It's uncertain how these microscopic particles could have appeared on the surface of the space station. The organisms are not typical for the location in Kazakhstan where the space station lifted off. Plankton in these stages of development could be found on the surface of oceans. There may have been some uplifting of air currents that had them reach the station, but if that's the case, then there should be a lot of it in orbit, one would think." And next page.
Space monkeys.
Just touch it.
So NASA, whoops, too far. NASA says, as far as we're concerned, we haven't heard any official reports from our Roscosmos, the Russian space agency colleagues, that they found sea plankton. What they're actually looking for is residues that can build up on the visually sensitive elements like windows, as well as just the hull of the ship itself that will build up whenever they do thruster firings and for things like reboosts. That's what they were taking samples for. I don't know where all the sea plankton talk is coming from. Reports, I looked at this, reports begin to fade away a couple days after that, and I could find nothing since then. So I think this is a pretty much dead story.
Pravda.
Now this one,
I smell a couple.
this next story was pretty interesting. When I was doing the research on this, I felt like I was going down the rabbit hole because there were so many links to links to links to links and things, and I tried to put all the best stuff in here. But what we've got here are two twins who are both astronauts. So twin astronauts ready to shed blood for space exploration, and that could lead to insights into some of the hottest topics in biomedicines. It says last year, NASA revealed that Mark and Scott Kelly, the only identical twins who are astronauts, volunteered themselves for study, yikes, creating a unique opportunity to disentangle the health effects of space on the human body from those of genetics. Mark, a retired astronaut, will remain on Earth while Scott spends a year aboard the ISS. NASA has revealed 10 experiments to be performed on them. They gathered proposals from academia and government agencies. Some of the projects will examine well-known health effects such as eye problems covered by low gravity, which affect a quarter of all the IAS inhabitants. Others will look at topics that are relatively or completely new to space medicines, including looking at the genetic changes resulting from cosmic radiation, or at the differences in gut bacteria due to low gravity and astronaut diets. Some microbes studies began on the IAS only this year, so we've got a lot to learn. Yeah.
Go to your next
They
slide.
study the twin paradox.
So yeah, the eye problems they're looking at. They're looking at difference in gut bacteria. Yeah, these are some of the problems. Astronauts on the space station, they're suffering from bulging optic nerves and things like that. So there's some serious problems with the eye. They're also looking at difference. Sometimes microbes in your gut in a couple days in microgravity can change their genome and become toxic. So this is something they'd like to investigate further.
As far as the eye changes, I mean, Mark has spent a lot of time in orbit already.
It doesn't affect everybody, but it does affect some. There's a whole article on that. I can get you that.
Okay.
Like I said, this is a rabbit hole. And the other one, which I thought Dale would find interesting, is genetic changes resulting from DNA being smacked by cosmic rays. Let's save some time.
Seems like we really need a control twin who's never been to
So,
space.
and this one is pretty interesting. I'd never heard the term telomeres before, but these are end caps on chromosomes that prevent them from unwinding, and they shorten as cells divide. And apparently, they're a good judge of age of cells, and they're going to be looking at the differences between these on the two astronauts. And they're going to be assessing cognitive abilities, spatial orientation, risk tolerance. How do you do risk tolerance? I don't know. But they're gonna,
Get in my business.
These are already people strapping themselves to an explosive.
You're gonna have them do it.
but no, that was pretty much it.
All right, keep going.
He's
You
gonna
got
come
this
back
part.
younger.
Huh?
This is the loss of
Yes, indeed.
the space. Tyler,
I
Bill, Dan, you
didn't have that one in there.
Okay, all right, that's fine. Just briefly, just to follow up, we lost an astronomer. I mean, we lost an astronaut, a pre-astronaut, if you want, Bill Dane, who flew the X-plane, and he died this year at 83 years old. And did you get the levitor bit? This is a suspends a ball in liquid metal in space, and on the ISS they were able to use this electromagnetic levitor developed by the European Space Agency. It's delivered to the International Space Station. The device allows the formation of solid metals to be studied while limiting the effects of gravity without requiring a container to hold the liquid. That's the end of that story. So let's move on. Our next presenter, and try and trim it a little bit, is me, and I'll trim this real quick. We had eclipses in 2014.
Do you want me to run it?
What?
Do you
I
have me to
got it.
run it?
I got to read some of it anyway, so let me. The first thing was the lunar eclipse of April the 15th, which none of us got to see because it was cloudy. And it was mostly in Europe anyway. But there's a little bit, they called it the spectacular blood moon.
Wait,
We said different.
Did we see the
places.
14th? No, we didn't see the one on the 14th.
I saw that one.
Did you? Okay. And
yeah,
then
you drove to Indiana.
there's a real good picture of that, photo of that. And then there was some clouds there, and took care of that. And the 15th was not the greatest of them all. And then we woke up to a lunar eclipse on October the 8th, which we all got to see. It was relatively low. It actually set while it was total. And we got to see that, and that was kind of special as far as I'm concerned. I thought that was a great one. And then, of course, this is the area of which the lunar eclipse was, and you can see that it was a sunset in our area. And the middle of the eclipse was obviously out in the Atlantic. The people out in California got to see it, Washington in particular, completely. And then we had that, this shows the actual total eclipse of the moon passing through the middle of the Earth's shadow, so it was a relatively long eclipse based on that from beginning to end. We had a partial solar eclipse that we got to see on October the 23rd. And that was pretty special too. And we got that, and it was a sunset partial eclipse. And my grandsons, who are 9 years old, got to see their first eclipse, which I thought that was kind of special. And actually, just to follow up on that, I'm going to see the total solar eclipse in March in the Netherlands, coming up. And there's a very nice photo of it, and we had a very massive sunspot there, which Jeff will cover in a minute. That was actually on the surface of the sun during this eclipse. And that picture was done by Al Linden and Jerry Korchak, who have visited our meetings on occasion, and I was of course assisting them. And mine only took 2 minutes, so I picked up a couple of seconds that the other guys didn't.
I can
So
beat that.
our next presenter is Jeff McLeod, who's going to do a presentation on several aspects of solar activity that occurred this year. Two. Jeff, go for it.
All right, thank you. Source of sun's power revealed by ghostly particles, that being the neutrino. And basically what this boils down to is the latest and greatest neutrino detector has proved its validity by discovering the lowest energy neutrino that we know about. I call it the double P neutrino, or PP neutrino, and I believe that means for proton-proton neutrino. And basically the theory that they were proving is that most of the neutrinos that we're detecting right now are hundreds of thousands of years old because they formed at the center of the sun and have to work their way out. And what they're trying to do is find the ones that zip right through the sun straight to the detector.
is there neutrinos that didn't do that?
Apparently they did. Or no, I'm
It's like
sorry.
photons. Photons. Yeah.
I did this today on my lunch break. So
He got roped into this last night, so.
it's called the boric xenodetector, and like many neutrino detectors, it's buried about 2/3 of a mile underground, surrounded by 100 tons of water. It uses a scintillator material that emits light when it's excited. So when a neutrino comes in and happens to hit that, it sets off the detector. They went through a long campaign to actually verify that they were seeing what they wanted to see and not background radiation and all that. And basically, they did find what they were looking for, and it adds a lot of weight to our standard model for the solar, or the sun. And the reason that this is so important, the reason it interests me researching it, is that the standard model right now does not encompass or factor in the weight of neutrinos at all, which I thought was pretty surprising. And so with more of this, we're going to be able to hopefully discern the masses of different neutrinos over time. I think about 3 minutes. Yes, okay. Massive flares erupt from the largest sunspot in 25 years. You can probably just go straight to the next one. This is that sunspot that Ken was talking about in the last clip, with some other things there to give you some size. This was roughly 129,000 kilometers across. I did some fuzzy math and found that if you were to take a Boeing 747 from one side to the other, it would take you just under 6 days nonstop to complete that journey. The flares were responsible for, I would call it, minor radio blackouts, but it put enough of a spook to really get a buzz going about these kind of events. The thing that was probably most surprising about the largest sunspot we've seen in 25 years is that there were no coronal mass ejections from this solar flare.
And when was that?
Yeah, we were lucky.
This was October 25th, 26th, 26th.
19th of October is when it really started its.
Yeah, it lasted for 3 weeks. I don't know if it came back around. It did come back around.
What isn't anywhere near as
Yeah.
impressive.
Let's see. 90% of sunspots do produce coronal mass ejections, and so we just don't know whether it's the kind of thing that once they get to a certain size, it changes the dynamics or what's really going on there.
Yeah, it was flaring like crazy. They were
Yes.
expecting
Yeah.
to see me.
So no aurora from the largest sunspot, which was kind of a disappointment, but and this, I guess the
It saved your modern world though, so.
Yes, and that's why this became a story, because everyone was so relieved when this thing went away, apparently. It was just like, apparently, because it didn't cause disaster, it was almost assuredly to cause disaster if it wouldn't have, which doesn't make any sense. But so I guess we dodged a bullet on that sunspot.
More like a cannonball.
Yeah. I think it'd be fun. I'm the only one that's
Wasn't it?
ready to be plunged into the 1800s.
Yeah, and I was just gonna say, the 1800s is when they had one of these, and
Yes.
the telegraph wires.
1859.
Burned down telegraph offices.
There are large
Yeah, there was even reports of it coming in down the line and melting equipment.
It set fire. I mean, it
Yeah.
burned down at least 2 telegraph offices.
I told
Huge
this
arcs.
story to a
Well, luckily
7-year-old
we don't have
kid.
telegraph lines anymore, so.
We only have, we
One of
only
these
have an
events would
electronic
melt
grid.
all the
Our next
transmission
presenter,
transformers.
thank you, Jeff, very much for helping me out on that one. Universe Physics Discoveries, this is by Joe Tocco. And we have a bunch of them that occurred this last year, and Joe is going to enlighten us, our observatory chairman.
Talking about physics to a room full of physicists. That's always fun. Okay. Water found in stardust suggests life is universal.
Yeah. Or-
Gotta go over
Yeah.
So put it next.
Go for it.
A sprinkling of stardust is as magical as it sounds. The dust grains that float through our solar system contain tiny pockets of water which form when they are zapped by a blast of charged wind from the air. From the sun. The chemical reaction causing this to happen has previously been mimicked in laboratories, but this is the first time water has been found trapped inside real stardust. Combined with the previous findings of organic compounds in interplanetary dust, the findings or the results suggest that these grains contain the basic ingredients needed for life. As similar dust grains are thought to be found in the solar system all over the universe, this bodes well for the existence of life across the cosmos. The implications are potentially huge, says Hope Ishii of the University of Hawaii in Honolulu. She's one of the researchers behind the study. It's a particularly thrilling possibility that this influx of dust on the surfaces of the solar system bodies has acted as a continuous rainfall of little reaction vessels containing both water and organics needed for the eventual origin of life. So, systems are full of dust, a result of many processes, including the breakup of comets. John Bradley of the Lawrence Livermore National Lab in California and his colleagues inspected the outer layer of interplanetary dust particles extracted from the Earth's stratosphere. Ultra-high resolution microscopy, I think, microscopy, allowed them to probe 5 to 25 micrometer specks of dust to reveal small pockets of trapped water just beneath the surface. Laboratory experiments offered clues to how the water forms. The dust is mostly made up of silicates, which contain oxygen. As it travels through space, it encounters the solar wind. The stream of charged particles, including high-energy hydrogen ions, is ejected from the sun's atmosphere. When the two collide, hydrogen and oxygen combine to make water. As interplanetary dust is thought to have rained down on early Earth, it is likely that the stuff brought water to our planet, although it is difficult to conceive how it could account for the millions of cubic gallons of water that cover the Earth today. In no way do we suggest that this was sufficient to form oceans, says Ishii. Big Bird's space neutrino has the highest energy yet seen. First there was Bertin Ernie, now there is Big Bird. This isn't a flashback to the birth of Sesame Street, but the latest in the hunt for subatomic particles from deep space. Big Bird is a playful nickname given to the highest energy cosmic neutrino ever detected. Neutrinos are nearly massless particles that are churned out by the sun and by processes on Earth, such as radioactive decay. They are also generated in deep space by objects such as supernovas and supermassive black holes at the center of galaxies. Only recently have we started systematically detecting these cosmic neutrinos, which tend to hit at higher energies than those produced in our solar system. Astronomers hope to read them as if they are cosmic messengers. Many particles get deflected or absorbed as they cross the universe, so they don't hold a faithful record of where they came from. But neutrinos barely interact with anything, and so arrive at Earth almost unscathed, which means they could be used to piece together details of the distant events that produced them. Last year, the IceCube neutrino detector at the South Pole, designed specifically to investigate cosmic neutrinos, reported its first catch, a signal consistent with two high-energy particles, which the team nicknamed Bert and Ernie. Each had an energy of about 1 million billion electron volts, otherwise known as a petra-electron volt. These were soon followed by an additional haul of 26 neutrino candidates, not quite as energetic as Bert and Ernie, but most likely cosmic in origin. Then in November, all 28 were confirmed. By then, the team had also peeked at some partially analyzed data and caught a glimpse of what looked like a neutrino of even higher energy, which they aptly named Big Bird. Now Big Bird has official status, appearing in 2 reports presented last week by the IceCube team members at the American Astrophysical Society meeting at Savannah, Georgia. It is more energetic than Bertin Ernie by approximately a factor of 2, says Ice Cube member Chris Weaver. And so it is the most energetic neutrino ever detected. The updated analysis also confirmed that we have not seen any neutrinos of higher energy other than Big Bird.
So Joe, what would constitute Snuffleupagus?
That's a good question. That is probably the one question I could answer, right?
Let's do this one real quick.
Yep. Oh, how do we get, okay.
That's it.
Well, the rumors over the Big Bang ripple-ifying are no longer rumors, as Ken mentioned in the report earlier. That whole finding has been debunked. So, next.
Yep, on my way. There we go.
Great.
There you go.
Okay, we missed the supernova, but
Yeah.
that's okay.
I think it's further on in your thing, so.
All right. Milky Way's dark matter, half of what we thought. Australian astronomers say that Milky Way galaxy has only half the dark matter we thought it did. If so, it explains the shortage of Milky Way satellites. Artist's conception of a halo of dark matter around the Milky Way image. Australian astronomers have now chimed in on the subject of why our Milky Way galaxy has fewer orbiting satellites than a prevailing theory of the universe. Cold dark matter theory says it should. They say the reason is that, according to their measurements, there's only half the amount of dark matter in the Milky Way as previously thought, only 800 billion times the mass of our sun. Their ideas are the latest in a series of widely varying researches, all attempting to explain the missing Milky Way satellites. Australian astrophysicists, and any luck with that pronunciation?
Let me give it to me. Pradral Kafel,
All right.
but it's not really germane to it, but go ahead.
No. Anyway, his team used a method developed almost 100 years ago, before dark matter was a gleam in any astrophysicist's eye, even to measure dark matter. The famous British astronomer James Jeans devised the technique in 1915. Dr. Kafal, who was originally from Nepal, says he and his team were able to measure the mass of the dark matter in the Milky Way by studying the speed of stars throughout the galaxy. He says they probed to the edge of the Milky Way for the first time, looking closely at the fringes of the galaxy, some over 500,000 light years from Earth.
Joe.
Which one?
That's the one you're looking for.
All right. Supernova found aligned with galactic magnifying glass. A perfectly arranged exploding star in distant galaxy have created a cosmic magnifying glass that could improve our understanding of the universe's expansion and dark matter. Sometimes when a white dwarf star dies, it explodes as a supernova. All supernova in this class reach a very specific color and peak brightness, creating what astronomers call a standard candle. As a result, any deviations from the standard brightness and color indicate whether, and by how much, the light from the supernova is being messed up by other things, like nearby galaxies or the expansion of the universe. For example, the gravity from a massive object like a galaxy can magnify the light from another object, like a supernova, bending its light and focusing them like a lens. We can only see this effect from Earth if the two objects are perfectly aligned. Now a team led by Robert Quimbley of the University of Tokyo has confirmed the first case of this lensing effect in a type 1a supernova, its light being lensed by the galaxy in front of it. Can you go back to that?
Yeah, I
Is that
can.
the Einstein,
Go for it.
the Einstein
Got it.
process? So, galactic magnifying glasses are not new. Gravitational lenses are the result of massive celestial objects like stars, galaxies, or even dark matter, bending light as it passes near them. Sometimes the gravitational lenses produce multiple images of a single object behind them. The effect is similar to looking at a candle through the base of a wine glass. The first gravitational lens was found in 1979, not long ago. The researchers identified a double quasar as a double image of one and the same quasar. It was produced by a gravitational lens. Einstein's cross, shown here, is a lensed quasar discovered in 1985 in the constellation Pegasus. According to current interpretations of redshift, the quasar is located about 8 billion light years from Earth, while the lensing galaxy is located at the distance of just 400 million light years.
You gotta go fast through the rest of them.
All right. First quadruple star image produced from a galaxy. Go to the next slide. There we go. For the first time, astronomers have seen an image of a single supernova split into four by gravitational lens. The splintered stellar explosion may help calibrate distances across the universe. This is the same reason that the previous slide, it's the lensing effect.
Last one.
Was the last one. Giant galactic gas blowout seen for the first time. This is a galactic equivalent of steam shooting out of a pressure cooker. For the first time, a colorful jet of gas has been spotted being forced out of a galaxy by just the pressure of the stars forming at the galactic center. The sighting, made by a team led by James Geach, the University of Hertfordshire in Hatfield, Britain, while measuring gas around a compact galaxy, showed that the energy from a growing central black hole isn't necessarily required for such a blowout to occur, as was previously assumed. The huge amount of gas in the jet, which is being blasted out at up to 625 miles per second, could form the equivalent of more than 1 billion suns. The loss of so much material would have had a major impact on the evolution of any galaxy, causing the stellar nursery to rapidly shut down. We are witnessing the aggressive termination of star formation, says Geach.
Thank you very much. Our next presenter is Diane Hall with the Planetary Missions and Finds. Diane, you're on deck.
All right, I'm gonna need the presenter notes.
Get to it. Maybe.
Right, so I just took out of the Planetary Missions and Finds, I took a few of my favorites. Some of them are not necessarily the most significant of the year, they're the ones that I liked.
There you go.
All right, so, numero uno, new dwarf planet hints at worlds beyond Pluto. This story will not die. So in 2012, an object, VP-113, aka Biden, in honor of the current vice president, was discovered beyond the Kuiper Belt. That makes two objects now found beyond the Kuiper Belt, Biden and Sedna. Both of them have weird orbits. Sedna was already known to be an oddball. And after the team that discovered Biden then analyzed more objects, 10 of them in total, that lie a bit closer to the sun in the Kuiper Belt. And they found some orbital peculiarities, the sort that hint that there might be something out there, a cosmic puppeteer of some kind that's altering the orbit of these objects. So, one explanation that they calculated is a rocky planet 10 times the mass of the Earth, 250 astronomical units out there. Well, why haven't we found it yet? When the WISE mission, the infrared survey, was looking for large planets out there beyond the Kuiper Belt, they were looking for gas giants. A rocky world would be much colder and wouldn't show up. It would be very cold, very faint, gravitationally massive enough to cause perturbations in the orbits of these little objects, but very difficult to spot. So, is a world or even two worlds out there? Possibly. And this story is probably not going to go away for a long, long time because so far we can't prove a negative. Next.
Oops, sorry.
This one.
That was.
We're
That
good.
was the, oh yeah, sorry, that was the orbital thing, yeah.
Okay.
Yeah, so you can see the orbits of Sedna, which is really whacked, and Biden, which is the green one that's pretty eccentric but not nearly as weird as
How many
Sedna.
Earth masses?
10. Or there's two of them with the less mass, you know, about 10 masses combined.
Next one.
All right, astronaut misses Earth by 25,000 miles. September 7th, this thing whizzed by the Earth. Its closest approach was over New Zealand. Astronomers were able to track it visually. The significant thing here is we've got a band of satellites that's 22,000 miles up. This thing was 25. It was grazing us. This was close. You know, it's a 60-foot object, not too impressive. Was discovered by the Catalina Sky Survey in Tucson, which you'll be hearing more later in the year, and confirmed by the Pan-STARRS, sorry, in Hawaii. So it's just another warning that we don't have any plan whatsoever if one of these did happen to blunder about 5,000 feet closer to us.
This would only destroy a few blocks, right?
Yeah, it would take out a nice chunk of satellites. So, yeah, just another close call to let us all know that we have no way of dealing with this problem yet. Lunar impact theory confirmed. Well, not really, but, you know, I like this theory. It's the Theia theory that the early Earth was smacked real hard by an object about the size of Mars, that in a catastrophe that obliterated the smaller body, really messed us up, and ultimately formed the moon. So scientists from the universities of Göttingen, Cologne, and Münster claim that telltale isotopes in lunar rocks indicate that, yes, this is correct. I've already seen things this year saying it's probably not correct, but I like this hypothesis, so let's cheer it on. And then, Ken mentioned this in passing earlier today, but Uranus is usually the most boring planet in the solar system to observe. Nothing happens. It's got rings, they're dark. It's got moons, they're small. It's got a very bland surface. And come August, it's starting to get really exciting. Researchers at the Keck noticed these brilliant visible storms in the northern hemisphere, 8 in total over the course of the year. And we don't really know what's going on. At its equinox, which happened in 2007, you might expect that the constant exposure to the sun would cause something interesting. The equinox came and went, nothing happened. And yet, here we are, 2014, and Uranus is really hopping. And to this date, nobody knows quite what is going on there. Yes?
Is it my imagination or are there cloud bands on the left image?
They do appear to be, yeah.
Is it possible that Neptune and Uranus are very similar and we just happen to catch Neptune at a prime moment of activity as Voyager 2 went by?
That is as plausible a hypothesis as
'Cause
anything.
if Voyager 2 had been going by Uranus while this was happening, we'd be like, wow, Uranus is exciting.
And Neptune's really boring,
Chuck,
yeah.
you're gonna lose your
But
report at the end if we don't get
Yeah.
going. So you're gonna lose your.
Neptune has a dark spot, though.
Yeah, it's
Yes,
okay. Guys,
multiple ones.
really, we have to
Okay.
move on.
So I'm going to just cede this one to Chuck because I wanted to talk about the specific race of the scientists to get data out of Philae, but Chuck's going to be telling you quite a bit about Philae, so I will yield to him on this one.
Okay, good. Let's move on. Thank you. We really have to step it up now. When you read your report, please don't do the whole report. Summate, please, going forward. Otherwise, we don't make it. Bob, you now the solar system moon finds, please.
Okay.
And we have to stop the questions from the audience because that takes a minute and we don't have it.
Yeah.
So,
We're going to actually go through these real quickly. The bottom line is, there's a famous reporter a few years ago that always used to end his talks by saying, now for the rest of the story. Well, a lot of these things, such as this is very exciting. first water plume seen from Jupiter moon Europa. There was all kinds of excitement, not only because they saw the water coming up, but there was also discussion that perhaps we don't want to go to the surface because we might contaminate it. So we said, well, there's water coming up into space. We can capture this water in some sort of a space vehicle, take it back and study it and see if there's some life in it. But it turns out that actually this was all bogus because they found out that we weren't able to actually see that. They think that was actually a misreport. They said there was 125-mile water jets, but they found out that really they didn't really see it. They think they just had some anomaly. Which probably is interesting because as a result of that, NASA kind of got a kick in the behind to start trying to go there. And it's like they're going to go there. So maybe that's something good that came of that. Okay? Ian?
Go ahead.
Okay. That was it. You don't need to find life on Europa. They were saying that we could just sample this water being blasted out into space and see it. So that didn't, that doesn't work out. There's a very Lake Superior seen in Saturn's moon, Enceladus, and stories out on that. We don't know for certain, but there could be a lake below there. And it supposedly can hold as much water as our Lake Superior. Okay, next.
Moving.
That's the same one. You can continue on from there.
Okay.
And plate tectonics found in Europa. This could be interesting because the plate tectonics could be a warming type of thing that could cause geological action, similar to like you might have on the Earth. So that more's out on that. We're going to find more about that, but that could be an exciting thing. So again, it's an exciting place you want to go to investigate on the Earth. Mysterious feature evolved in height and sea, and it's all bogus. So,
What?
Well, that was, they saw some stuff there, but.
Was it real? Didn't they say that they thought that it was just a photographic, they saw it, but it wasn't, it's like the moon on Mars, the face on Mars, depending which way you turn it, it looks like nothing. And again, here's Europa's guys who disappear in a cloud of mystery because they don't really know, they don't think they really capture those. They show up on one image, and it's very rare that they're able to go back and find them again. I think it was it 2012, I think they saw it. And that's it. The only time they ever think they saw it, and it's never happened again. It'd be great if they had this happening all the time, but unfortunately it didn't happen.
Okay, thank you,
Okay,
Bob.
that's fast
We'll
enough.
see you again.
Yeah, you did
Okay.
great.
Okay, you're still up. You're on the
Oh,
exoplanet. It's an exoplanet.
Oh, okay. Exomoon.
Exomoon first one.
Hey, that's Jupiter.
Well, that was the first one. Yeah, back. Okay. This is the one, the first exomoon glimpsed, and they use gravitational lensing to find this. And then the bottom line was, after they used the gravitational lensing, then they qualified, like the qualifier is that this is a very unusual happenstance. We can find something with this gravitational lensing, and they probably would not ever be able to repeat it and see the same thing again. So again, they're keeping their fingers crossed. There might be something out there, but they're never going to go back and find it using that gravitational lensing again. And that might be an issue with any gravitational lensing. It's the type of thing that happens once, and it's probably not repeatable. Many solar systems found in the Milky Way. This is, jump around here, and this is our galaxy is teeming with small solar system lookalikes. More than 300 planetary systems reminiscent of our own have been found in data collected by NASA's premier Planet Hunter Kepler space telescopes. And they add to this unexpected diversity of exoplanets that exist in the Milky Way. So, yeah. More following that. And this was the planet which they thought was the most Earth-like planet yet. And I think that one was also,
185, if it's 6F, is still a candidate.
I think it's very dubious. It might not actually exist.
yeah, so,
Yeah.
and first life may not exist.
There you go.
So there you go, that was it. So basically what they're saying is all the things get you excited during the year. As they said, now for the rest of the story. So it sounds like, very exciting, but whatever. And there was the first ice giant outside our solar system was found. And this was, I think, you got these out of work here, Ken.
It has sideways rings.
Pardon? Yeah, looks like
Gosh,
it's a
it looks
ring.
just
Oh,
like
this is-
Uranus.
They're just- these are
I
just-
guess they are artist rendition, I'm pretty sure.
This was the ship that they flew by it, right?
Yeah, yeah, this is a lot of these things, yeah, that's why I always worry about when I see something that's an artist rendition, because it says, wow, that's really awesome. He said, no, it's not. That's just an artist's picture, it's not really what they found. What they found was a little slight, radio wave or whatever. And this is the first action shot of a planet Earth around a young star.
This one's real.
Pardon?
This one's real.
That's, yeah, I'll say, this is a real one, this is a real one. And that was probably the first time they've done that. I think was that the one that was also done from the Earthbound telescope?
That was done from ALMA, the Atacama Large Millimeter
That was the
Array.
first one that they actually were able to do from
That's
Earth,
radio.
which is amazing, because they didn't have to go from outer space.
The world's
Okay, let's go.
largest radio telescope.
Going on, moving on to the IMPs and lunar volcanic action. That has to be a brief discussion,
All right, all right.
real brief.
Okay, well, I think it was Apollo 15 that first observed blotches on the moon that were not typical of the area around them. These blotches were like about a half a kilometer or a kilometer wide. But basically, over a period of, since Apollo 15, they've appeared, there's a total of 70 of these blotch-like appearances were found on the moon. As you can see in the Tranquility Sea, there's just a large grouping of them. And they're all on the near side, on our side of the moon. One of the first ones discovered, and this is what they look like. So what happened is that as they did some spectroscopic analysis of these blotches, they found that they were basically basaltic in nature, high in feldspar and quartz, very typical of a volcanic action. Here's another one. You can see, and you can see the concentration of impact strikes. And here you can see there's very, very few craters, very few areas where craters from impacts occurred. Here's one of the more famous ones. You can see there's no impacts in this area compared to the area around it. So what all this means, is there another one there? I think there's another picture. What this means is, what they've determined was that these blotches are really volcanic activity, that because they're pure, they feel that they happened within 50 to 100 million years ago. The current thinking was that volcanic activity on the moon ended about 1.5 billion years ago, and now all of a sudden we're finding evidence of very recent volcanic activity. This is the time of the dinosaurs, which was like kind of cosmic level. This is like yesterday. So basically, what the conclusion is that the moon is really, it's got a hot molten core, which we didn't think it had, and this is evidence that the moon is still active. So that's kind of interesting. It kind of changes our thinking and our knowledge of the moon based on these blotches that we found.
Great.
Okay.
Thank you, Angela.
Okay, ran through it.
Next coming in. Bob, you got Gail, Laddie, and you have less than 5 minutes to do it.
Oh, boy.
You have about 3 minutes to do it.
All right.
All right? Go for it.
All right, Gail.
You tucked it again.
I did. Back. Planetary Resources. This is a independent, private space company. I actually met these guys at a convention a few years ago. They want to find and mine asteroids. This is the Arca 3 space telescope. It was designed to test and validate some of their core technology. They want to place 10 of these in space and do spectroscopic analysis to find metal-rich asteroids. So this is that is the actual deal there. Project is backed by a whole bunch of famous people. Unfortunately, it suffered a launch failure. This thing it was on the Antares launch vehicle. It had the Arca was on this along with a science experiment designed by some Madison Heights High School students. So that was rather devastating for them, I'm sure. And well, they took it a lot better than I did, and they said, "Just a robot, guys. We'll make another one." So Hayabusa 2. This is the Japanese Space Agency. This is their second attempt at an asteroid sample return. This was going to sample asteroid 1993 JU3 in 2018, and it's also going to drop that on the surface of it. And this thing is really cool. It's going to drop several of these things. This thing has a device on it which will allow it to essentially hop around on the surface of this comet, and it's going to do sampling and stuff like that. And that's going to be very, very cool. Gaia was European Space Agency's cosmic explorer. It was launched on a Russian Soyuz. It is doing spectrophotometric measurements to provide detailed information on luminosity, temperature, gravity, composition, and direction that things are moving. It's going to be mapping about 1 billion stars, and it's expected to find tens of thousands of Jupiter-sized planets beyond the solar system, 500,000 quasars, and tens of thousands of new asteroids in our solar system. And there she is. There you go.
Thank you very much. Very well done.
Still have Laddie on there? Or?
Yeah, that's it.
Oh, Hubble. Oh, yeah, okay. Hubble Space Telescope just revealed the deepest view of the universe ever seen, and it relied on a traffic jam of galaxies to do it. This is the image called the Frontier Field. And again, we're talking about gravitational lenses. Oh, and we'll go on to Laddie now. And Laddie, this was a mission to investigate the lunar atmosphere, and it was quite an exciting mission. And what they did was it was scheduled at the end of mission to crash into the surface of the moon, and it did that, and you can see the area here where it left a crater right there. So,
Very good, thank
that
you.
was it. Oh, New Horizons. I'm not done yet. New Horizons. This mission has been on its way to Pluto for a long time, and much of its course it was in hibernation mode. It went through several hibernation modes. Well, it woke up on December 7th, and it is starting its mission to explore Pluto. It is going to be this is summer. June. I can't wait. This is going to be awesome.
We've already
There
got
it is,
pictures
that's the
back
group
from it.
that actually saw it,
Yep, they were very, very happy about it.
and we'll skip the
Skip
Hubble
that
thing
one,
next
okay.
time. All right. We'll
That's
skip that
actually a
one.
pretty cool graph. I've never
And of
seen
course,
that
the
before.
CubeSat craze could be a space debris catastrophe, just briefly, that they're sending up these small things that you've all heard about, and they're a little concerned about what they might result.
Watch the movie Gravity.
Right. And of course, we have Diane now just to briefly cover the SpaceX, the Orion and the Virgin Galactic.
Manned spaceflight highlights.
Or
Let's see.
lowlights.
How do we progress?
Top
this?
one.
Top one? All right, so Boeing and SpaceX got the contracts. The winners of the Space Taxi Prize, they have gotten, we will be going to space with Boeing and SpaceX vehicles. The big loser here, the company doing the Dream Chaser, Sierra Nevada, with its mini space shuttle. They had hoped to get this space taxi deal, and now they will have to look to Europe and Japan. And Orbital Sciences, we'll talk about them in a second, did not lose out because they're not participating in the manned spaceflight race. Now here's the Dragon capsule that was unveiled. What's different about this Dragon capsule is it's got seats. It's got 7 seats, flat screen panels, real snazzy. They unveiled it with actual colored lights, smoke effects and all that. And they're real proud of it. It's neat, and it will be able to land on solid ground and not just water. So this will be a really cool thing to watch progress. Okay. Meanwhile, NASA's got its own spacecraft, Orion, that did a successful 2-orbit flight of Earth on December 5th, a day that Charles Bolden, the NASA administrator, proclaimed as day 1 of the Mars era. So everything's looking good, except when it doesn't.
Just tap it.
Tap it. Okay.
And you're good.
Okay. This is all done. Yeah, that. Okay, Bob mentioned this. Orbital Sciences wants to fly unmanned vehicles to the ISS and be a pillar of commercial spaceflight. Unfortunately, their rocket flying cargo to the ISS exploded 14 seconds after liftoff on the 28th of October. Thankfully, no one was hurt, but the multiple science projects contributed by school children were destroyed, CubeSats were destroyed, 26 Earth observation satellites were lost, and the asteroid mining technology demonstrator that Bob mentioned was destroyed. So this was not a good day for commercial spaceflight, but then everything got a lot worse 3 days later when one of Virgin Galactic's Spaceship Two craft, this one was called Enterprise, broke apart in midair over Mojave, California. It crashed. The pilot, Peter Siebold, survived. Co-pilot Michael Alsbury did not. In this case, the feathering device designed to aid in re-entry deployed prematurely. Might have been pilot error, but error that the co-pilot would have paid for with his life. And Virgin Galactic CEO summed up this disaster with 3 words: space is hard.
You know, I'm making a suggestion. When is my presentation on that short one for astronomy?
Too late.
No. Let me ask you, when is my? Why don't we do this the proper way? We don't want to rush through the rest of the things. I'm scheduled to do a short presentation in another month or so. Okay?
Yeah.
When are you supposed to do it?
May.
May. We're going to have the second part of In the News, this one, in May instead of my presentation. You don't need my presentation. This is more important. So in May, we will do the rest of the presentation. And Chuck, we'll get you in there. We want to give it enough time. We only need another 15 minutes to do this, but we can't do that here. So we will do.
Can we
the
just
rest
let
of the
Chuck
In the
go?
News. What?
Can we just let Chuck do his slides and
If you want
in
to.
5 minutes?
If you got time, you can do it. Come on in.
Probably have 5 minutes.
All right, but I'm going to let him do it again. So in the other meeting, let me go through it.
I can do this in hurry-up mode. It
Okay,
won't
go ahead.
take too much time.
I'm going to be talking about Curiosity as one of the other major stories. These are the last 2 stories actually on our list, and we'll go to the lead story, which I think is the Rosetta Philae, and Chuck, you're going to do it, and we'll do both the Curiosity and Rosetta in that meeting, and it'll only take us.
I'll prompt you with next for each slide.
Okay, go ahead. Just go ahead. You're in.
So I'm going to talk here about Rosetta and Philae, which is actually a mission that will visit or has visited a comet. The timeline here at the bottom shows several Earth flybys, also a flyby of Mars after the launch date of 2004 through the time period about 2010. The part that gets interesting, though, is early in 2014 when the probe came out of hibernation and began to approach the comet with an August 6th arrival date. And there you can see a little bit of the path that it took, a spiraling multi-pass path. Next. So a little bit about this comet that was visited. So this is a European Space Agency project. And the comet is named 67P, and also bears the name of 2 Russians, Churyumov and Gerasimenko are their names, but it's easier to refer to it as 67B. And so here you can see the size, roughly about the same length as what Mount Fuji is high. And you can see it compared also to several important man-made structures, Eiffel Tower, Empire State Building, Burj Khalifa, which is in Dubai. Next. So, as I mentioned, there are 2 parts to this. There's Rosetta, which is the orbiter, and then there's Philae, which is the lander. And so there's a separation that took place, and that Rosetta was put into a close orbit so that Philae could be let go and allowed to impact on the surface. Next. So here's a kind of a view of all the different instruments that are on the Rosetta probe. So you have solar panels. Here you see Philae still attached. To just kind of sum up the different probes that are on there, kind of fall into 3 categories. Those that were designed to study the nucleus of the comet, those designed to look at the gas and the particles that are being given off by the comet, and then also to look at third set of instruments to look at solar wind interaction. As far as the nucleus, it's mostly imaging in various wavelengths of light, including radio and microwave, whereas gas and particles, mostly things like atomic force microscopy of captured particles, secondary ion mass spectrometry of particles to determine composition. Next. So as Rosetta approached, one of the first big discoveries was the fact that it wasn't just a single hunk of matter that was out there, but actually a double hunk of matter. So here you see on July 11th, 2014, taking it through a complete rotation, and you see that there are obviously 2 lobes there. Next. And that's when things started to get really interesting, is as Rosetta closed in, you got to see higher and higher resolution images. The shape was described as rubber duck-like in some publications. Next. And then here's another high resolution close-up view of the surface of the comet. Images like these were collected and scrutinized to try to find an ideal landing point for Philae, because obviously they couldn't really plan that too far in advance, because you don't want to land it in an improper location. So a lot of that had to be decided during the approach to figure out what the optimal landing point is. Next. One thing that Rosetta was able to determine from orbit by the instruments that I mentioned to you is was able to sniff some of the chemicals that were being emitted from the surface, determine some of the chemical composition of the comet, or at least that of the material, the vapors, the particles that are coming off. And 3 of the big things that I found was stinks of rotten eggs, which is actually hydrogen sulfide gas, CATLE, in other words ammonia, and then also hydrogen cyanide was found in good quantity as well. Next. One of the big things that Rosetta really wanted to determine was what is the water like. Obviously, water ice is a major component of comets, and they wanted to know, is the water that's there in the form of ice similar to the water that we have on Earth? Well, how they do this is that they looked to see what is the ratio of deuterium to hydrogen. So hydrogen, obviously H2O, water contains hydrogen, but you can also have deuterium instead of hydrogen. Deuterium basically is hydrogen with, instead of just having a proton in the nucleus, has a proton and a neutron in the nucleus. So one thing that they found is that the ratio of deuterated water to regular water is actually 3 times that of Earth, so a lot more deuterated water. So this kind of casts into question some of the theories regarding whether or not the water on Earth actually came from a cometary source. But there's still an open question, but this does seem to fly in the face of that idea. Next. Yes. So here's Philae, which is attached to the bottom of Rosetta. Next. As it's about to land, the idea was that you have the thruster pushes down, a harpoon that stabs the surface, and then also foot screws that would commence drilling upon landing in order to secure it to the surface. Next. So Philae, the lander, was designed to do a lot of things. In particular, it was supposed to probe the surface, essentially strike the surface with a hammer to determine what is the consistency of the surface, drill into the surface, collect a sample which could then be distributed to multiple different instruments to analyze. This was all planned. Had batteries and solar panels on there. The batteries would give 60 hours, solar panels would give additional time. Next. Well, the problem is that the landing didn't quite go as planned. So instead of having the harpoon stab into the surface,
the thruster failed first.
Well, yes. The bottom line, though, is that it bounced across the surface, so there are actually 2 major bounces. The first one, I think, took it almost
700 feet.
Yeah, it's a pretty good distance up into the air. And the problem is that it didn't land in the correct location and in the correct orientation. Next. So here's an image.
Oh, sorry. Wrong way. Sorry. Not back. We're good.
Okay. So here's an image actually taken from the orbiter.
We have to be out at 10,
Yeah.
at in 7 minutes, so.
That's good, that's good.
And
Okay.
so,
We can do
here
that.
I
the-
mean,
the
we have to
bottom line
be
is
cleared
you
out
can
of the
see
room in
that
7 minutes. so.
various points, and then you can see where one of the bounce points was by an impact
Sure, you
versus
can
no
take that.
impact, and then rather dangerously it's headed towards shadow next. And here's one of the first images from the surface taken by the lander. Next. And then there was really a race to try to get as much data as possible because it landed in a shadow, it was immobilized, it was sitting at an awkward angle, and they knew that the batteries would run out and they'd not be able to get the amount of solar energy that they anticipated. So as such, there was a race to really try to collect information. The drill was functional, but one of the bottom lines is that they weren't able to actually take any of the collected material and distribute it to other components. So they weren't really able to do a lot of tests that they had planned. Next. But a lot was done to try to determine the final resting place because there's an idea that, that even though it's in a bad spot that only gets a couple hours of, somewhere between an hour and a half and 4 hours of sunlight, maybe it can recover. Next. So the idea is that maybe with time, as the comet gets closer to the sun, there will be enough energy saved up from the sunlight exposure from the solar panels to recharge it enough that they can reactivate it at some point in the future to be able to maybe conduct some of these experiments. And that looks like the end.
Thank you very much.
That was exactly 10 minutes.
The one thing, while you're packing up, the thing you need to know about Curiosity, during the period of time, what Curiosity did is it found methane. And that was a very, very significant thing, that could be the excretion of some form of bacteria or some form of simple life of some sort. That was one of the most important things, and it also found a lot of water. So basically, that's the basic part of the Curiosity thing. And when we get to that meeting in May, I'll do a little bit more elaboration on that. It'll probably take about 5 minutes with it. But that's where you are. We did it. You know, with a little extra time, but we did it.
Think you do it.